All right, so hello, welcome to the CAD and 3D printing milestones course. I'm Andrew Pham. I am the course instructor. I'm here with David today, who's our TA. We are missing one of them. Her name is Brenda. She's taking an exam today, so good luck to her, and good luck to many people who emailed me about exams. But yeah, you're probably going to meet her next week, but you're just going to go quickly through some introductions and then just get started. So this is me. I'm Andrew Pham. I'm a junior in mechanical engineering here at Purdue. I'm from San Jose, California, which is in the Bay Area. I've been CADing for about 7 years, probably going on 8 soon. I've kind of lost count at this point, but I've been enjoying it. I like it a lot. I'm also a 3D printing enthusiast, so we're going to be talking about 3D printing later this course, and I can definitely talk your ear off, like expanding on the stuff that we talk about in class by a ridiculous margin. So if you are interested in 3D printing, feel free to ask at any time. I can yap about it. And a little fun fact about me is I was a barista, but I don't really drink coffee. I don't really like it. But I made it all. But yeah. But yeah, this is Brenda. She's also from San Jose, which is kind of funny. But yeah, she's taking her exam today. I think it's her ECE exam. So yeah, she's been CADing for about 5 years. She likes woodworking. She's pretty cool. But yeah, you'll meet her soon.
Hey guys, like Andrew said, I'm David. I'm actually a senior in ME now. From Cincinnati, Ohio. I'm doing CAD for about 6 years. I've called with Toyota twice, and I partake in ultimate frisbee items.
But yeah, that's just some quick intros. I'm sure you'll probably get to know us a little bit better as time goes on. But we're all here for you. Well, Brenda's here in spirit, but we're all here for you. Like, if you have any questions about this class, like either, during the lecture or outside of class, like, we want to be a good resource to you. So, like, that's partially why this course is conducted through Discord and not like Brightspace or something. And it's because, like, I want you to have quick access to us because I don't always read my emails and stuff like that. So it's usually easier if you just send me a message or message the whole like Discord. You'll probably find that some people might have similar questions to you and they might be too scared to ask. So if you want to ask and save someone the trouble of asking, that can be helpful. But yeah, we're here for you. The other reason the Discord is there is so you have access to these resources after you finish this class. Because if we run this class through Brightspace, we have to kick everyone out at the end, and then you kind of lose access to all this stuff. So you kind of have all of this stuff forever, which is something I think might be nice for you. And you also have access to, me and the TAs forever until, I don't know, I delete Discord or something. I don't know. But yeah, yeah, we're here for you. So, this is a pretty chill, casual class, so you can yell at me and stuff. I'm totally cool with it. But yeah. Cool? Yeah. Awesome. Okay, so this is just kind of a fun slide for me. These are just some of my previous CAD projects. I'm doing a bunch of other stuff currently, but at the end of this course, you will technically have the capability to do this. But I wouldn't be too intimidated by this because obviously I've been CADing for a very long time. But the goal of this course is to give you the resources and the knowledge to be able to make something like this. I think with a combination of what you learn in this class and maybe some physics and math, this stuff is all very attainable and possible. And as a reminder, this is a beginner-friendly course. So if you have zero CAD experience, I'm actually curious. Who has never CADed before? Never? You don't need to be scared. Okay, cool. Yeah, I mean, typically it's usually about half the class hasn't CADed before, but this seems a little bit smaller. There's probably a couple people who aren't here today who've never touched a CAD program. But yeah, this is beginner friendly. So if you don't know what you're doing and you're starting from zero, that's what we're here for. But yeah, if you do know how to CAD, we just hope that, this might be either a good refresher or it might teach you some, good foundations or like good practices that you may have missed when you first started learning. Because personally, when I started CADing, I was like self-taught and I was just messing around on the program. And there were a lot of things I did at the beginning that were probably not ideal. So hopefully this class can maybe clear some things up for you, and make you, more efficient, make your CAD a lot cleaner, easier to modify and stuff like that. But yeah, we're just gonna start by downloading Fusion just because it usually takes a while. So I have the installer links for all of you because you typically need to create an account to get the installer, but I find it faster to just start installing it and then making the account while it's installing. So if you go into the Discord, which I'm assuming everyone's on at this point, there's this resources tab. Every week when we have class, if we are using something in class or using a link or a download, it will most likely be here. So today, we have a bunch of links here. I think the one that you should start with is the Fusion 360 installer. So if you open it, it's just going to take you to a Google Drive folder. There's an exe and a DMG file. So the exe is for like Windows and stuff. And if you use a Mac, the DMG file is the one you want to download. Yeah, just download them. It's not a virus. I literally just downloaded them and put them here. So yeah, just download them. You might have to unzip them or something and then just run the installer. And once we get that all going, then we can talk a little bit more about the course while it's all running and stuff. Also, I think we have a couple people who've already installed it, so they're probably showing. Oh, okay. That, but basically it's just yes, yeah. So I'll actually get to that. But yeah. Hopefully okay, who's not running an installer right now? Okay. You should probably run it. Okay, so while it's running, I'm going to talk a little bit about the course, and then we're going to make the Autodesk accounts in a second. So if you haven't done that, don't worry. Basically, some people ask why we use Fusion 360 in this class. One of the big reasons is because it's free for us Purdue students. So if you didn't know, you can get an Autodesk account through Purdue using your Purdue email, which we're going to do in a second. And we find it's a very nice and like beginner friendly CAD program. It's very intuitive. You'll see the icons are, very nice. The UI is pretty clean. Compared to a lot of other CAD softwares like NX or something, those programs are a lot older and they look really outdated. Sometimes it can be a little bit hard to use. But the good thing is using it, or once you take this class and you know more about Fusion, a lot of the tools in Fusion apply to a very large majority of other CAD programs. So if you end up wanting to use SolidWorks or something, it's usually not too hard to pick it up. It's just icons are different shapes in different places. So for the most part, this app applies to many other CAD programs, but I think this one's a nice one to start like learning. But yeah, user friendly. Other thing, it's cloud-based, so you can it stores all your files on the cloud, which is kind of nice. You can, cross over multiple devices without, needing to bring a USB with all your files on it. And it's also nice for collaboration. So, I don't know if any of you have taken the toy design class at Purdue, which is ME 444. A vast majority of the students in that class end up using Fusion for their designs, and it's partially for the collaboration feature, right? You're going to be in groups of, 4, maybe 5 people, and then you can all work together on the same model or the same assembly. So it's pretty nice. But yeah, other programs do that too, but Fusion's we think is pretty decent at it. So yeah. Okay, class introduction. So I'm assuming all of you signed up through Milestones, or at least a vast majority of you did. If you didn't know, Milestones doesn't offer just this course. They offer a bunch of other kind of enrichment courses outside of, your normal curriculum at school or at Purdue. And then when you complete these courses, you get a certificate from us, as in Purdue. So it's not just like, me, some random junior at Purdue writing you cert. It's actually an official Purdue thing. So it usually takes a little while, but you will get it eventually. You better get it. But yeah, you'll get a cert for passing the class, which you'll see in a moment, or you'll see over the next few weeks. It's not that bad. But once you pass the course, I send a list of names of all the passing students to my boss, and then he sends it to his boss, and then she sends it to someone else at Purdue. And that usually takes about 2 or 3 months for them to fully process. Once I send it, it's kind of out of my hands, but I promise you that it'll come. I know people kind of get anxiety over it because they're like, when is it coming? Is it going to come? It will come. It'll just take a while. But yeah, I will keep you posted on the status when I can, but usually it's just kind of not like given until it's given. So I usually don't have a ton of updates, but I'll try to keep you all informed so you're not worried about it. But yeah, we're hoping like once you pass in the spring, you'll probably get it, sometime over the summer. I'd hope before school starts in the fall, but sometimes it takes longer. But yeah, they will come eventually. In terms of course objectives, obviously we want to teach you why CAD is important and why you're taking this class. We want to teach you all the skills you need to make whatever model that you want, and then we're also going to teach you how to render them and like 3D print them at the end, which is kind of fun. If you didn't know, this class is not run, well, it's run through Milestones in collaboration with an organization called ASME here at Purdue, which stands for the American Society of Mechanical Engineers. So both David and I are part of this organization, and that's how we can that's why we collaborate with Milestones to bring this class to you. So they've taught this class for a while, and then they've handed it off to us so they can develop new programs, and then we help to maintain and improve them, after they're handed off. So we can bring them to you, which we really enjoy, but we also, like advertising our organization. So you're going to hear about this for the next couple slides. Basically, if you're ever interested in ASME, we do stuff like this, like leadership opportunities, a lot of different things. We also do professional development and stuff like that. But yeah, we have a bunch of different design teams if you're interested. Some of these slides are slightly outdated, but we have a bunch of different things for wide varieties of interests. So if you're interested in any of these or the next couple of slides, you might want to check it out. I did small projects for a little while. It's pretty cool. Basically have 1 semester to create some kind of thing around a set of rules that, some people in the club make. And then at the end, there's usually some kind of competition. It's pretty cool. But there's a bunch of other things for different interests as well. I know we've been doing pretty good in Grand Prix over the last couple years, so it's something we're pretty proud of. But yeah, there's also a lot of more stuff. I know we have like a rover team and other stuff like that that aren't on here. But yeah, it's pretty interesting. There's a lot of cool stuff going on, and you don't have to be an ME to take or to be in this organization. We have like business majors or other, you know, wide varieties of majors in this organization. So if you're interested, you're more than welcome to join. Yeah, it talked about professional development. So if you want help with your resume and stuff, sometimes we host sessions to do, you know, stuff like that. It's pretty cool. But yeah, if you're interested, there's a Slack that you can join. So this QR code should work. I believe I checked it last time. But yeah, also you have access to these slides. So if you ever miss something, you can go back and look at them. So yeah. And then if this QR code doesn't work for any reason, you can just ask me and we can figure something out. Yeah. Any questions about ASME that I can try to answer? No? Okay, cool. Anyways, going back to more information about the class. This is a 5-week or 5-lecture course. Obviously, this is week 1. So we meet every Monday from 5:30 to 7:30 p.m. in this classroom. You know, we have 5 different modules, kind of self-explanatory. And you do have a final for this class, which I'm going to go into in a little bit. But yeah, you know, same time, same place every week. Should be pretty straightforward. In terms of the breakdown for the assignments of this class, I try to keep the rubric pretty open and accessible to you. So this is kind of a breakdown of how many points everything is worth. I also post the rubrics for everything. So if you're unsure about what we're grading on, we have it for every assignment. So if you're wondering why you're getting points off, typically look at the rubric, or, you know, I'll be writing feedback if you get points off. But yeah, this is basically the point breakdown, and you just have to pass this class. This is not like a, you know, A, B, C class. It's just a pass or fail, right? So you just need a 70% to pass, which you'll see is pretty lax, especially because I do a majority of these assignments in class. So that's why I encourage everyone to come to class, and that's why attendance is like mandatory. So, you know, if you come to class, sit in and just kind of follow along, you're probably going to get like at least 50% or more, right? So that's already pretty close. And then, you know, you have a couple other assignments outside of class, which is homework and your final. So if you follow along, come to class, you should be pretty good to go. Like, our pass rates are usually in the 80s to 90%. So like, most people pass. So I would hope everyone does, but yeah. In terms of the attendance, requirement, I basically have it as no unexcused absences, right? So I know you have life going on, you have a bunch of other stuff outside of this class. This class usually isn't the biggest priority for everyone because, you know, it doesn't count towards your GPA and stuff, which I totally understand. You obviously have exams like Brenda and other people today, and I would much rather you go to your exam than, you know, fail your class and show up here, right? So if you're going to be gone for whatever reason, you're sick, you have an exam or something, we have attendance forms. So if you're going to be gone, please fill out the absence form. So I know that, you know, you're acknowledging that you're not going to be here, but then you're still saying that you're committed to the class, right? So the biggest reason people don't pass is because they just stop showing up and stop turning things in. So this is just kind of there as a reminder and be like, hey, I'm going to be gone. I have an exam, but I'm going to catch up on this stuff that we did this week, like on my own free time, right? So again, I post everything. I have lectures for all the weeks whenever we have class. I'll record it and then I'll post it to YouTube and I'll send it to everyone. So if you either, you know, if I was either going too fast in class and you missed something, or you're gone and you need to watch it, it's going to be there for you. And then obviously you can ask us questions. We're more than happy to answer stuff. So we're trying to set you up for success here. Again, it's a pretty chill class. So, you know, I would hope that in the 80s or 90% of you will pass, if not more. So yeah. Any questions about this? About attendance? No? Okay. In terms of homework is due right before the next class. So, we have the assignments that we're doing in class today and the homework. All of that is going to be due, at 5:29 before next week on Monday. And then the final will be due at midnight the week after week 5. So I think that's Monday at midnight on dead week. So, yeah. Does that make sense? Basically, I just have 1 week for class. Yeah. All right. In terms of your final, which I guess I just talked about, some of this might make sense to you, some of it might not. But basically, your final is basically making something from your brain, making whatever you want. The main requirement is that it's not something we did in class already, which is kind of self-explanatory. But the other constraint is that it must have at least 5 design features. You're going to be learning about creating these design features in class. So if you don't know what that is, don't worry about it. And then the last requirement here, which I don't think is on this slide, is that it must be designed for manufacturing or with manufacturing in mind, right? Because you have the option to 3D print your finals. I don't want you to design some really awesome thing and then send it to me for me to try to print it, and then I just can't print it because it's either like too small or something like that, or it's just going to break when I take it off the build plate. So we're going to be teaching you how to design for manufacturing, but that's one of the requirements we have because, we don't want to hand you a sad pile of plastic that's like destroyed at the end of class, and then you're just going to be sad, and I'm going to be sad too. So hopefully that doesn't happen. But yeah, it's pretty chill if you know about design features, and you've added stuff before. You'll kind of come realize that 5 design features is really not that much. A lot of the assignments we do in class, or some of them we do in class, will have 5 if not more. So it's not something you should be super worried about. But yeah, there are a number of students who like to spend a lot of time on their finals and then make really awesome stuff like this. I would say these are very exceptional finals, and I really like seeing them. But if you have a bunch of other stuff to do, I know finals and midterms are always something that people are worried about more than this class, which I understand. Your final doesn't have to look this complex, but it totally can, and we definitely encourage it. But again, you just need a 70% to pass. So I wouldn't blame you if you're like, dude, I'm super busy. I need to just get something done and turn it in and just send it. That's totally fine. I understand. So yeah. Any questions about the final? I'm assuming you're probably gonna have more questions as we get closer, but I'm happy to answer now. All right. Okay, so now we're going to be making our Autodesk accounts. If you haven't already, there's this registration link right here. You just want to click it. It'll ask you to put in some information. Please use your Purdue email because obviously, because we're getting it free through Purdue, they need to know that you go here. And one of the ways they know that is by using your Purdue email. So use your Purdue email. Agree to the terms and conditions that you totally read. But it'll probably look different for me because I already have an account. Yeah, but it'll probably ask you for some information that I can't input because I already did. Sometimes they ask you for extra verification because they don't think you go to Purdue for some reason. And if that's the case, you can go here, I believe. and then right here, it'll probably have Fusion or something right here, and then you'll say access. I mean, I already did it, so it's probably gonna be hard for me to get there. But it might ask you for some extra information like Purdue's address and stuff like that. So Purdue's address is here if you're interested. The website, if they ask you for it, is just purdue.edu. But if they ask for any other information, you can probably just Google it. They might ask for like a Purdue phone number. But I think it's usually just these two, but I don't remember. But yeah, I'm just gonna walk around the room for a little bit, make sure everyone is squared away, because making your account and installing Fusion typically has some pains for some people. It's typically not their fault, and it's just Autodesk being Autodesk. So I wouldn't worry too much, but we're gonna make sure everyone's set up well for the rest of the class. Okay, so go through the extra confirmation. But back out of this, it should be together. Should update the log application. Free trial is not for me, but as long as the browser side, it should update. No, so, just make sure that's all filled out.
So it all goes to have something for. That's just verify the revenue of real institution. Job, everyone will be, oh, no, it's one. Choose, 610 for them all. Yeah, it's on. Yes. You get it. Yeah. I think you're good. We can get started. Is that and additional allowance. Did you make it in that?
Yeah. Oh, yeah.
I would say do something to my YouTube, but I just want to make first out of first do, and now people just want to kind of think. Over that. Because that's really one of the things. I would assume that, like,
Honestly, this is the first time
here, oh, I see your name. Yeah.
but it doesn't matter.
Good. It's up. Whatever you want, sir. It doesn't really change. Oh, okay, so. Yeah. I should ask you for. Yep, that's how the question, I don't confuse the two buttons. Okay. Something.
Okay, so here's what is medications very good with that. So actually, I need to say if I think it's so nice. They got the results. Things like that. Maybe whatever is what I need. Yeah.
Yes. You can be careful of other spaces. All of one. Yes. But. See what they come about. So that's not big. The first thing. So you have to. I mean, if we have this knowledge. We're gonna start. If we get decided if we're gonna move back to it's just about asking this for. Really concept of it is design and was asking. What's the shape of that? A lot of it. So it's it's go whatever feels right to you. I shouldn't ignite anything, it's just take it for one thing. And I get down that vision first time, I didn't have this or anything, so this is all kind of done, there's like trying to conquer it. You'd be okay. Yep.
I would say that's. It's not. It's not, yeah. So honestly. That no, sir. That's what the. What's your purpose for the file? Yeah.
Who doesn't have Fusion installed at this? It's okay if you have it, but we just want to make sure everything's good. Okay. And who has, if you look in like the top left corner or the top of the like Fusion's like navigation bar, the window, raise your hand if it says like trial for 30 days or something. Okay.
So,
No. Okay, you probably did.
it happens a lot.
Yeah, it doesn't, yeah, for some reason, if you have a Purdue email, it doesn't
To
count.
be fair, I get like phishing and scam emails from Purdue emails, so I would be sus too.
Yeah, I don't know.
So all of it. So all of who we.
Yeah. Okay. So hopefully we're good now. How are we going tonight? Okay. All right. So now that everyone has Fusion installed, which is great, we're just gonna jump in and start modeling stuff. So if you didn't know, CAD stands for computer aided design, because before CAD existed, people just drew a bunch of lines and stuff on paper, and it used to take a long time. There are a bunch of people in like whole like rooms dedicated to people making part drawings for designs. But now you can do that on your computer, which is pretty awesome. You know, before that, some smart dude at MIT, just for some background, you know, made the first CAD program. You can see doing it on this giant room-sized computer. But now people CAD on like their iPads and stuff, which is kind of crazy. So technology has progressed pretty pretty rapidly, and you know, it allows us to make pretty advanced designs with, you know, it lowers the barrier to entry, which is really nice. So yeah, if you're interested, you know, feel free to read this slide. It's just like history. But yeah, obviously there are a bunch of different applications for CAD. I would say most of the things that you interact with on a day-to-day basis have probably been modeled in CAD at some point. You know, especially like computers and stuff, someone has to design it. Some smart engineer at, you know, Windows or Microsoft or something, used a CAD program to, you know, design your laptop or your monitor or whatever thing that you're sitting in, your car, all that stuff. And they also use CAD programs to simulate things before they make it, right? So a lot of CAD programs have simulation tools, which is why a lot of companies market their CAD programs as CAD packages, because it comes as not just a CAD tool, but also like simulation tools. We're not really going to go into simulation in this class, but we have an FEA class through Milestones. So if you're interested in FEA and stuff like that, it's also based in Fusion. So after taking this class, you'll be familiar with the UI. And if you want to learn more, you can do that. It's pretty cool. But yeah, CAD programs are pretty powerful. They also, a lot of them have CAM programs, which allows you to program a CNC machine to manufacture your part. Again, that's not something we really are covering in this class, but it is an option if you have Fusion. And if you didn't know, Fusion CAM is pretty widely regarded as one of the best CAM programs. So, you know, a lot of people will model things in other programs and use Fusion exclusively to write CAM programs because their CAM is pretty good. So, yeah, it's pretty cool. Anyways, yeah, I was talking about other CAD programs. Obviously, Fusion isn't the only one here. Personally, I started learning on SolidWorks, but once I started, once I took this class and then took over this class, I use Fusion a lot as well. But again, there's a lot of parallels and crossovers between all these programs. So once you learn Fusion, you should be able to do a lot of the other ones. So if you look at some people's resumes, once they have one CAD program, they'll pretty quickly amass other programs as they, take on different projects and work for different companies. Each company has their preference in CAD programs. So, you might need a couple of weeks to get super proficient at the next program. But once you get this nice foundation, it's pretty much the same everywhere. But yeah. Anyways, we're just going to jump right into it. We're going to make a couple simple building blocks. I saw some people have started already, but I'm just going to run through it with everyone who hasn't. So I'm going to open Fusion real quick. It likes to be slow. Or it likes to not launch at all. All right, there we go. Some of you were asking about like Fusion hubs because probably have a fresh account. It'll ask you to create hub, and that basically is just asking you to name your default folder for where you're going to put everything. So you can kind of name it whatever you want. I think mine is just my name or something. I honestly kind of forgot. Wow, okay, it's slow today. Also, out of curiosity, who does not have a mouse today? Okay, that's fine. I also don't have a mouse, but I recommend you bring a mouse because it usually makes CAD a little bit more easy, or at least like moving and manipulating your part is easier with a mouse. Unless you have a middle click button like I do on my laptop. Wait, you have a ThinkPad, so you're fine, I think, right? Yeah, okay. But anyways, middle click can kind of be an important button that you need when you're CADing stuff, because to orbit and stuff like that, you kind of need it. So I would recommend a mouse, but you can get away without it because I typically forget my mouse because I'm forgetful. So it's possible, but sometimes it's just a little annoying. But no, I don't want to update now. Anyways, I'm just going to start out in Fusion here. I think it defaults to dark mode now, but sometimes it defaults to light mode. I don't really know. I'm going to be talking about constraints a lot in this class. So when something is fully constrained, if you're in dark mode, the line or the arc or whatever thing you're constraining will turn white. If you're in light mode, it'll turn black. So I might use like fully black or fully white interchangeably, but just know that you're going to be looking for, one of those two colors depending on your theme. But yeah, I have dark theme on, so my stuff is gonna look white, but your goal, if you have a light theme, is to make all your lines and arcs black. But you're gonna understand that a little bit more in a little bit. But anyways, this is kind of your workspace. You can see this big, blank area is kind of where you're going to be creating your models. If you don't have this grid pattern and you want it, there's this grid and snaps area here, and then there's that layout grid. So you can toggle it on or off through your preference. In terms of manipulation, you're going to be zooming in and out a lot. So again, if you have a mouse with a scroll wheel, that's nice. But you can zoom in and out just by scrolling. You can move side to side, I think, with holding the middle click button. So it's like panning side to side. It's like this. That can be useful. But my mouse controls are backwards. But the default is control and middle, or I think just middle click for panning side to side. And then you can also orbit, which is like spinning around stuff. Maybe I'll just open something so it's easier to see. Okay, yeah, we're gonna do this in a minute, but yeah, panning side to side, I'm pretty sure is middle click. And then orbit, I think is shift middle or control middle, one of the two. But I personally use orbit a lot more than, panning side to side. So I mapped it to just be middle click, which is the default for SolidWorks. So that's just my mouse preference. But if you're using the Fusion default, I think it's shift middle. But yeah, if you don't have a mouse, there's something up here called the view cube, and you can kind of drag your mouse and just hold down and orbit as well. So if you don't have a mouse, that can be useful. But yeah, that's just kind of moving around. You're going to be doing it a lot, so you're going to get very proficient at it. But yeah. In terms of like this top bar here, I'm going to refer to this as your toolbar. This is where you're going to, select all the different operations and tools that you're going to use when making your models. Over here on the side is something that Fusion calls the data panel. And this is just kind of like your Google Drive or your File Explorer. It's where you store everything. So you can organize it in files and stuff like that, or files and folders. So for me, I have like a milestones folder. I think it defaults to look like this. I definitely recommend you make like a new project for this class. Some people put it in like the admin project on accident, and I think there's like a weird maximum and it gets hard to find your files. So I definitely recommend you make a new project. And then in there you can add folders or do whatever you like. But yeah. Okay, I'm going to make a new folder for this session. And we're going to make some cool stuff. So if you ever want to hide the data panel, there's like this array of squares here, so you can show and hide it. I typically have it hidden just so it's easier for everyone to see, and it usually makes the toolbar a little bit easier to use. But if you ever need to open stuff for like assemblies, you can open it. The other thing here is on the bottom, there's something called the timeline. So for week 1, it's not super necessary that I need to see it, but for some of the assignments, I do want to see this. So we're going to talk about assignment submissions in a little bit, but basically you're just going to take screenshots of your work, and then you're going to submit it on a Google form. So when you submit it, please have your timeline visible, including this bottom, but also your model, obviously, because I want to see it. I'm not going to take off points if you don't have your timeline for week 1, but for week 2 and beyond, I think it's subject to like 20% off. So if you want free points, just get in the habit of doing a full screenshot or something. But yeah, I'm just telling you now, I would like to see that in the future, because you'll see in a moment that every time you make something, it will add a little feature in the timeline, and I can kind of read it to see what you did to get to the model that I can see. So if you did something in a way that wasn't intended, then you might get points off, because sometimes we ask you to do things in a specific way just so you can prove that you know how to use certain tools, right? So again, everyone has their own preference when it comes to CAD because there's typically more than one way of doing things. A lot of the times, I might recommend you do something a certain way. And, you know, after this class, it's totally chill if you want to do something else. But typically we ask you to do it in a certain way because we're showing you a new tool that we haven't used yet. So it's just showing you how you can apply these tools, but you can apply them in many different ways. So, like we're going to talk about extrudes and revolves in a little bit. And there's several ways you can achieve the same geometry with a completely different like tool. So we're going to show you that in a little bit. Does that make sense? Again, week one, I kind of ramble a lot because it's just kind of setting foundations. But hopefully, you know, as the weeks go by, things will get a little bit faster because I know some people with CAD experience are like sleeping right now because you're like, bro, you haven't even made a sketch yet. But we're about to do that. So yeah. All right. So for the first assignment, we're just going to make these kind of building blocks here. I typically start with this cube and then I do the cylinder and then this little bridge looking piece. So if you want to make a new design, which it probably defaults to open one, but just click there. We're mainly doing part designs because typically we're modeling individual parts. For this demo, I'm modeling 3 different things in the same part, but typically I just make one part in a single design. But if you want to do multi-part designs, that's fine too. But yeah. Anyways, I'm just going to do part design. I'm going to create a new one. For the units, I use millimeters, but that's just my preference. For most assignments, it doesn't matter to me what dimension or units you use. So if you want to CAD in like kilometers, then that's totally chill. There's, I think, 1 or 2 assignments where it does matter, and I will tell you. So if you're worried about like something not being the exact same unit or exact same dimension as me, I wouldn't worry about it because I will tell you when it is important. So for the week 1, it doesn't really matter. So yeah. All right. Also, if you ever wanted to change your units, you can go into document settings and edit them here. So if you ever need to change that, it's there. Anyways, with that out of the way, I'm just going to start modeling. I'm going to start with that cube here. So the first thing I'm going to do, which you're going to do a lot of the time, is making a sketch. So you're going to become very proficient at making them, but it's just here in the top left corner. You can see here it highlights these kind of orange areas, and these are the 3 default planes that Fusion gives to you. You know, typically you're just going to pick one, but if you care about the orientation, which it might matter later, you can kind of use the view cube to figure out where you are in space, right? So the top is here. So this here's the top plane, and then these are like the front one. This is the front plane, and then this is the right plane. So I'm just going to use the top plane, but for this assignment, it doesn't really matter. But yeah, you'll see it kind of snaps to the plane that you selected, and then you can start modeling and drawing your sketch. You can see the toolbar changes to have all the sketch tools. So in this case, I'm going to make a square. So, you know, I'm going to choose rectangle here, and then I'm going to draw a rectangle. So in terms of practice on where you should place that rectangle, or just where you should start your sketches in general, I definitely recommend you start at the origin. So the origin is this little like gray circle in the center, and it's the only defined point in space when you first start your design, right? There's nothing there except for that point. So it's typically good practice to build off of that position, right? If you don't have, or if you don't draw it from the origin, then you're going to have to add more things to fully constrain it. And I can show you in just a moment. So I'm going to start from the origin. I'm going to use the 2-point rectangle, start there and drag it out, all right? So you can see, we have a rectangle here. But the lines are two different colors, right? These two vertical and horizontal lines are white because they're constrained by the origin here, right? So because I started this point here, I can't move this vertical line left or right, and I can't move this horizontal line up and down, right? If I tried to drag it, it's not going to go anywhere. But these two don't have any defined points. So I can drag this up and down and this side to side, right? But we want to fully constrain this, right? Because theoretically, I could, make and extrude this sketch here and it would be fine. But I could also drag this and it's like not precise, it's ambiguous. So to lock things down, I'm going to use the sketch dimension tool, which is right here. The hotcut is D, or shortcut is D if you like using shortcuts. But you just click on it. You click on the line or point of interest, drag it out, and then specify some dimension. I'm just going to go with 100. You can see when I applied that, this line turned white, right? It's fully defined because I can't move this side to side anymore. If I tried dragging it, it doesn't do anything. If I do the same thing over here to this vertical line, now both of them are white, right? Again, if you're using the light theme, these should all be black. But once all of these colors are white or black, you can see I can't move anything around, and that means it's fully constrained. So that's what we're looking for typically in most of these sketches. It's just good practice to have them fully constrained. There's very specific scenarios where you don't want them to be constrained, but that's very, very rare. But yeah. Okay, so the reason why I specified starting your sketch at the origin is because if you didn't do it, you need to add extra dimensions to fully constrain it, right? So I have this rectangle here, and I'm going to do the same thing, right? I'm going to do 100 here, 100 there, but you can see it's still blue, and it's because it's not constrained in space anywhere, right? These lengths are constrained, but there's no positional constraint because it's not constrained to the origin. So to fix that, I would have to add more dimensions to specify where it is. Right, so once I add these extra ones, this point is defined in relation to the origin, and then this becomes fully constrained, right? But typically, if you design things well, you don't have to do this very often, because if you just use the origin, it just saves you 2 extra dimensions. And typically, people like to make symmetrical parts, so basing something off the origin might help you overlap different features later. So yeah, that's why I typically start things at the origin. Obviously, you can do whatever you want, but I think it's best practice to start at the origin. So I'm going to leave it like this. We have this square. Looks good. Once you're finished with your sketch, you're going to just click the check mark here, and it's finished, right? You can see I'm going to orbit around. It's just a 2D square on this plane here. It looks good. But now I'm going to make it 3D, right? So to do that, I'm going to use the extrude function, where you basically select some kind of profile and then you just pull it in one direction to make it 3D. So you can see it auto-selected this because there's only one area. But if you didn't, you would just click on this closed area. It'll get highlighted, and then you can drag it, or you can specify the distance here. So I dragged it like the perfect amount. But the other dimensions were 100, so I'm going to set this as 100 as well. But there's also a bunch of different things that you can choose. We're not really going to get into this today, but there are scenarios where you might want to change these. But typically the default with the profile plane and some specified distance is what people start with. So this looks good. We select OK, and then we have a nice cube. Good. I know I'm going like super slow for like one cube, but it's mainly just to establish like good foundations with fundamentals. So you're going to see now that I hope that you understand all of this. I'm going to go a little bit faster now. Does that make sense? I'm hoping these fundamentals are setting in. Cool. Okay. So with that out of the way, we have this nice cube here. Now I'm going to make this cylinder now. So I'm basically going to do the same thing, and then I'm going to go against the rule that I just kind of gave you and draw something off the origin, but it's mostly just because I'm doing multi-part stuff in a single design, which you typically won't do. So I'm going to draw a circle here. I typically avoid drawing them on these like vertical or horizontal lines because sometimes it may look like it's in the right spot, but it's not fully constrained, right? So I have this circle here. I'm going to apply some dimensions. You can see for a circle, you typically only need to specify the diameter, but because I'm not at the origin, I have to specify 2 more. But for this one, you can see if I did the same thing, you know, this looks like, let's say I really wanted it to be in this position, right? This looks correct, but the circle is still blue. And it's because the like horizontal constraint is like constrained here, but it's not technically constrained vertically, even though it's in the right position, right? I drew the circle on this line because that's where I wanted it to be, but there's no like official constraint constraining it to this red line. So if I like dragged it, you can see I can move it around, which is not desirable. So in this case, you need to add something. So I'm just gonna, you know, add another dimension here. And now it's fully constrained. So keep that in mind. I typically, when I draw sketches, I'll draw things in a way that they're slightly incorrect, and then I'll make sure I go back and constrain it properly. It's just, I found it was kind of helpful just after CADing for a while to draw things weird and then constraining them. Because if you draw them correctly, it'll look right, and you're like, that looks right, why isn't it constrained? It's typically because there's an unspecified constraint that needs to happen for it to be locked in that spot. But yeah. Anyways, I'm just gonna delete this and extrude this. So I'm gonna do the same thing, finish the sketch, and then extrude it. Do like 200 this time. Looks good. Yeah. Okay. Who needs more time on this? All right, sweet. Okay, so for the last one here, we have this building block. There's a couple ways you could go about doing it, right? You can make a rectangular prism similar to this cube here, and then you can cut away this half circle, right? And that's like 2 different operations, and you could do that. That's technically valid. But what I'm going to do is I'm going to do them both at the same time, right? And, you know, depending on your model and what you want to do to it, either way might be the better decision. In this case, because this geometry is pretty simple, I'm just going to do it all in one. But, you know, if you have certain things that you want to change independently, sometimes splitting up the different features might be desirable. In this case, I'm just going to do all in one. So I'm going to make another sketch. Instead of selecting one of the default planes, I'm just going to show you that you can select another plane or face. So instead of these kind of orange sections, I can select something else, like, this face on this cube, right? So if you want to build off of it, you might want to select it, and then, in some cases, if you're building geometry off of something else, like, making a hole in something, typically select that face and then draw your sketch. But I'm just doing some other stuff over here, drawing a rectangle, gonna add some constraints. Like this. So I have this rectangle here. I want this kind of half circle cut out. So I'm gonna draw a circle on top of it. I want it to be centered, so it's gonna snap. Fusion will kind of snap to like different important sections of a line, and one of them is the midpoint. So you'll see once I get close to the middle, it'll snap there with like a triangle symbol, and that's just the midpoint symbol. So I'm going to draw a circle from the midpoint, and then I'm going to add a dimension here. This looks good to me. You can see here that our model is taking shape, but I also have some extra stuff that I may not want. So you technically could just like extrude this from here, but I'm going to teach you how to trim stuff away if you don't want it. So there's these scissors up here on the toolbar, which is the trim tool, and you can select that and cut away. So you can either click on the line or the arc that you want to get rid of, and it'll highlight red, or you can hold down like left click and then drag your mouse through it, as if you're cutting it. So I'll trim that away, and then I'll also trim this bottom line away. In this case, when I did that, you can see that the circle turned blue again, and it's because it's unconstrained, right? When we made the circle, we constrained it to the center or the midpoint of that line on the bottom, but we just cut that line away, and that midpoint doesn't exist anymore, right? So because of that, this line or this circle can, move side to side, which is not something that we want in this case. So to fix that, I could do some math. I could do like 300 minus 160 divided by 2, or I can have Fusion do it for me. So we're going to talk about this a little bit more next week, but there's something called geometric constraints where you can apply, some geometric property to certain things. In this case, for this to be centered, I want these two lines to be the same length. So there's this equal constraint. So I'm going to select equal, click these two lines, and then it'll center that circle, and now it's fully constrained. So that's what we're kind of looking for there. So that looks good. The other thing to note is that you can see here whenever I move my mouse over this section, it gets kind of highlighted, and that means it's a closed body, right? So sometimes if you're making a more complex sketch and you want to extrude it, you should make sure that the inside is highlighted blue, or that you can move your mouse over and it kind of highlights this area. Because, for example, let's say I was making like this triangle here and I like just slightly missed this endpoint. You can see obviously it's a triangle, but it's not closed because these 2 points aren't on top of each other. So I won't be able to extrude this. But if I, made these two or combine those 2 points, you can see I can highlight it now. So that's kind of what we want. If you're wondering why you can't extrude something, it's typically because you might have 2 points that are like super, super close together, and like you just missed it like this. Because like when you zoom out, they look about the same, but sometimes they're not actually in the same spot. So you have to do that. Anyways, this looks good to me, so I'm just going to extrude it. If you're interested, the hotcut for extruding is just E. So I'm just going to press E. I'm going to select the profile, and then, I'm going to extrude it. That's good. Okay. Who needs more time on this? Okay. Yeah.
Should I make the circle kind of cut out of the way?
Yeah, sure. So we're here, right? Um, there's this trim tool up here, and the shortcut is T. So when I select the scissors, you can see if I highlight my mouse over it, it'll kind of turn red, and if I click it, it disappears. But I can also hold left click and move my mouse around and then run it through the line that I'm getting rid of. So I'll run through this one, and then it'll disappear. And then you have to make these two equal to constrain the circle horizontally, like that. Any other questions? No? Okay. The extruding?
Yeah. I guess after.
Oh, the equal thing? Yeah. So you can see the circle is blue, or the arc is blue. You can either hold shift and click these two bottom lines and they highlight blue, and then you can click equal up here, or you can click equal and then click on the two lines. The order doesn't really matter. Okay, everyone good here?
I don't think so. Maybe I can go.
The circle?
It's so good.
Okay. So I have the rectangle, right? Okay, so the rectangle is fully constrained. I drew the circle on the midpoint of the bottom line, right? So it will constrain it to that point. I, specified the diameter, and then I trimmed away all the stuff I didn't need. And then when you do that, you have to add something. And in this case, I added the equal, and that made it fully constrained. All right, are we good now? Okay. The last thing for this assignment and for a couple other assignments is adding appearances. So you can see, there's different colored blocks on the assignment slide, and we're going to ask you to do that as well. When you apply appearances, I request that you, choose a color that's not very dark, like a gray or a black. Because if you choose a color that's very close to this default, then I'm going to assume that you didn't do it and you might lose points. So if you, make it green or something, it's going to be pretty obvious that you changed it. And that's just kind of what I want to see. So to apply appearances, the shortcut is pressing A to open the appearance library. You'll kind of get a pop-up like this. And then you can, specify some kind of color or material. For a lot of this stuff, I usually just go for just paint, like glossy paint. For each appearance, you typically have to download it. So, I downloaded blue already and a couple other colors. And it's literally just drag and drop. So you just drag the blue or whatever color to the body that you're looking to apply it to. It's just like that. Does that make sense? Yep. Okay. Any other questions for this assignment? It's pretty straightforward, I would hope. Okay. But yeah, basically, now that you have this, assuming you've been following along, just take a screenshot and you get full points, obviously. So, that's just 10 free points to you for showing up to class and doing it. which is why we recommend you come. But yeah, that's assignment 1 for you. If you press A on your keyboard, it'll open the appearance library. I think it's also under like, I forget where it is. You can also like right click the body and then open the appearances that way, I think. Yeah. Okay, so it's about 7 p.m. now. We have 2 more assignments to go through. So now that I hope that you have some good fundamentals down, I'm going to go a little bit faster on these 2. But yeah. Everyone good? All right, cool. So I'm going to save this. I'm going to make a new design, new part design, and then I'm going to want to create this hammer. So there's a couple ways you could do it. You can, extrude this cylinder, make this rectangular prism, and then extrude another cylinder on top of it. But what I'm going to do is extrude an extra long cylinder and then make a rectangular prism that phases through the original cylinder, right? Again, both ways are totally valid. I just wanted to do it this way to kind of show you a couple of different operations or differences in operations, just to kind of show you different tools. So I'm going to make a sketch, draw a circle real quick. Again, it's at the center, so all I have to do is specify this diameter on the origin. Looks good. I'm going to extrude it. In this case, I'm probably going to extrude it like a lot. So I have this cylinder, and then I'm going to make this rectangular prism on top of it. So I'm just going to say that like this face here is the bottom and this one's the top. So I'm going to make a sketch on the top face of this cylinder, and then I'm going to extrude it at an offset to kind of have this feature on top. So I'm going to create a sketch here, click on the top face, and then I'm going to draw my rectangle. Again, because it's centered at the origin, it makes things a little bit easier because I can create a center point rectangle, which is, if you go under create and rectangle, there's a center rectangle tool. And then I can just start at the origin and drag it out, right? If I didn't draw this circle at the origin, I'd then have to, draw this rectangle and then constrain it to the center of the circle, which is just a little bit more work. Again, you can if you want to, but typically I don't recommend it. I'm going to specify some height and width. So 500 seems fair. Maybe like 250. So this looks good. I don't know, maybe I want it a little bit bigger. You can see here, because I selected this top face, the sketch is on that face, right? But we want that little thing on top. So when we go to extrude it, we can do some extra stuff. So I'm going to extrude. I'm going to select this profile here. And then instead of starting at the profile plane, which is where we created the sketch, we're going to start it at an offset. So in this case, the arrow is pointing upwards, which means the positive direction is upwards. We want it to be offset downwards. So I'm going to specify some negative offset. And then I'm going to extrude it at some distance. So because that arrow is going up, again, the extrusion is going to be negative. Um, okay, yeah, that looks good. But you can kind of see what's going on here, right? This blue section is where we created this sketch, and you can see there's a nice gap because I created this negative offset right here. And then you can see, you know, I extruded this 300 millimeters downwards. In this case, it's the negative direction. So that's what we're looking for. You can see here the operation is set to join, and that basically means it's going to combine this rectangular prism with that cylinder we made. If you happen to select the rectangle and also this circle, it might turn red, right? And you can see the operation changes to cut. And you kind of get a preview here. When it gets set to cut, it just cuts away at this whole rectangular prisms area or volume in that specified region. So if I apply that, you know, obviously this isn't the hammer I'm going for. So I'm going to need to change the operation from cut to join. Fusion will often try to assume what you want to do. Oftentimes it's right, but sometimes it's wrong. So sometimes you need to specify that manually. So I'm setting it to join. That looks good to me. For the last thing on this, I need to apply a fillet to all these corners on the head of the hammer. So you can see in the screenshot on the slides, there's some rounded corners. So to achieve that, we're going to add something called a fillet. So I'm going to open the fillet tool and I'm going to select some edges. So I'll just start with these. And then I can specify a fillet radius. So maybe it's like some number like 30. Now I have these rounded corners. One interesting thing about Fusion is you can nest certain operations inside of each other. So like I can make this fillet, but then I can also nest a different fillet in the same feature. So a lot of other programs, if you want to make like fillets or chamfers of different sizes, you're going to have to make like, oh, one fillet at like 20 millimeters and you select all the lines. And then, you know, one fillet at 30 millimeters and you have to, you know, close the initial fillet and then you have to make a new one. Fusion's interesting because you can nest them. So in this case, let's say I want these edges to be a lot larger than these edges. I can specify this fillet here, and then I can add another selection set and then pick some other lines and specify different radius. So I think it's pretty cool. I'm just going to select these faces, so it'll automatically select all 4 of the edges. And when I specify this radius, let's do like 30, for example, you can see that this radius is, you know, a lot larger than this one. But you can get the same, or you can get all of this in one feature in your timeline. So, you know, this can be a nice like efficiency thing if you want to make your timeline cleaner. It's definitely an option. So, yeah. So that looks good to me. Again, the same thing could be achieved with 2 different fillets. So, you know, I could do like U4 at 60 and then like make another fillet at 30, right? And it achieves the same thing, right? But in the timeline, it has 2 different ones instead of what I did before, where it's like only one. So it's a little bit more compact, kind of nice. So that might be something desirable to you. But yeah. Everyone good on this one? Again, it's a lot faster than last time, so.
Oh, so this is that. What is how you set it up the rectangle or the circular?
Yeah. So, you know, you're here, you make the sketch, and then it defaults to like the 2-point rectangle up here, but you can make a center rectangle by going down under the create menu. And then because we drew this at the origin, you just start at the origin and drag it out, and then it'll be centered.
So if our did a 3-point, is there a way so we could make it a something back there?
I mean, I honestly would just delete it and make a new one. It's sometimes a lot faster to just like delete something and redraw it. But technically speaking, like you could create a 2-point rectangle, right? And then how they do the center point rectangle is they have 2 lines going diagonal. And then like the midpoint, I'm just going to do one. The midpoint of this is on the center of the origin. So you could do that. So again, it achieves the same thing. It's just a little bit more work. So I'm lazy and I just like making Fusion do it for me. So yeah, either way is acceptable though. Any other questions? Not symmetric.
But I wouldn't click through it to see which one is which. See like now, it's missing that. It's or that.
Okay. Any other questions? Okay, cool. So with that, I'm going to do the last assignment for today, which is this game piece. It's again, you're going to be using similar sketching techniques, but instead of extruding, we're going to do something called a revolve. So, you know, if you've taken calculus and you did like the disc and washer unit and stuff like that, this is essentially the same thing, but just like applied in a CAD program, right? We're going to draw some profile, we're going to revolve it around an axis, and it's going to create a solid body. So I'm going to save this. New design. And then I'm going to create a sketch. So in this case, I'm going to be choosing the front plane because this red line is kind of the bottom to me. And then I'm going to start drawing. So we're going to kind of replicate this profile here. I typically start with the straight lines. So, you know, I'm going to go a vertical line, that horizontal line going up to the origin, and then another vertical line here. We have an arc here or a circle, and then this line going diagonally to another arc. So what I'm going to do, I'm going to draw a circle. I'm going to draw a line. And then I'm going to draw an arc. So 3-point arc. You could also draw a circle and then connect these points if you wanted to. I'm just going to do an arc though. So just like that. But yeah. So we have a very demented looking game piece. This doesn't look like what we want. But for me, I just like throwing down a bunch of lines and stuff. And then I trim and then add constraints as necessary. So you can kind of see what we're going after, but we need to add some more stuff. So I'm going to start to add some dimensions. For this one, you can also specify angles. So you can see this line is, not parallel or perpendicular to this. So I can specify an angle by clicking on the two lines. And now you can see, as I'm adding more dimensions to it, some more features are turning white, which is what we're looking for, right? The last thing here that's unconstrained is this arc right here. So I need to constrain it. So what I'm going to do here is kind of more of a week 2 thing, but I'm going to add a geometric constraint, in this case, a tangent constraint. So I'm going to make this arc have like a smooth transition to this line with the tangent constraint. So I'm going to click the tangent tool, specify these two, and you can see now it's nice and smooth. So once I specify a radius here, it should be fully constrained. Yeah, this is looking pretty solid, right? We have this core geometry in. We have some extra stuff that we want to trim away. So I'm going to start trimming. You can see I can trim this side, but if I try to trim this side, it'll cut away the whole circle, which is kind of not what we're going after. It's because, there's no line in between here and there. So I'm going to have to add another one here. And then once I have that, then I can trim away, and we have this game piece profile here. The trim, yeah. So again, we're here. We have this vertical line going to the center of the circle, but we don't have the line extending beyond to the edge. So I'm adding another line here. So you can see if I move my mouse over here, it highlights this profile, and then I can trim it away like that.
What about that part of the circle that's
This bottom one. So, I mean, you should just be able to trim away no problem, assuming this line is on the circle, right? The endpoint of this line is on the circle. If I trim it, you can see it'll trim between this vertical line and this diagonal line here. Okay, who needs more time with this?
But yeah. So, yeah, whole body. Yeah. Uh, oh, yeah. Yes. Yeah. So like, and this boss. Yeah. So sketches finished. Yeah. Yes. Yes. I don't know if you like to do it all. But,
Okay. Who needs more time with this? Because we have like 10 more minutes. So I might just finish this up and then again, I record everything, so I'll post it. So if you're a little bit behind, that's totally fine. Um, and I'll also be here after class for a little bit. So, yeah. Okay, so with this finished here, we have this nice profile. Instead of extruding it like before, the tool right next to it is the revolve tool. So again, it'll ask you to select the profile. In this case, it selects it for me because there's only one selectable profile. But then it'll ask for an axis, right? You need to choose the right one. So, let's say I clicked on this one on accident. This isn't really what we're going after, right? It's kind of like a inverted weird thing. Or like if I clicked on this one, it looks like some weird washer. We want to select the right axis, which is in this case this one here, and then we have this nice little game piece. So you can see again this profile is blue, and then it gets revolved 360 degrees to create this solid body. So that looks good to me. The only other thing we have to do is apply an appearance and then add a name or just like something on the bottom. So I'm going to do the text first. So I'm going to make a sketch on the bottom here. And then if you ever want to insert text, you go create text. There's two different types. You can just have like a free open one that just kind of is a box, or you can make it on a path. So if you draw like an arc or a line and you want the text to follow it, you can do that. I'm just going to make a simple box today, but you can do that if you desire. So, you can write whatever you like. You can change font and size and stuff like that, but I'm just going to leave it as is. And then I'm going to extrude the text into the game piece. So this looks good. I'm going to extrude it. For some reason, it thinks I want to extrude the whole face of the game piece, but I only want the text. So I'm going to delete the profile selection and then specify the text. You can see here the arrow is going outwards. So if I made, a positive number, it's like extruding outwards. But I want it to go the other way, so I'm going to make it negative. You can see it changes the operation to cut, which is what we want. And when I confirm it, you can see the cut or the text is like embossed into the game piece. I think you do.
Did you get that PSA about between the quotes?
Oh, yeah. That's a good point. For the text, you want to make sure whatever you're writing is in between like the little apostrophes. I think if you don't have them, it just doesn't show up at all. So, if you have something outside, it's not going to like it either. So make sure you have your text in between the apostrophes. Yeah, I always forget.
It's all good.
Yes. And the last thing here is just applying an appearance. So adding some color, and then you're good to go. For this assignment, because there's something on the bottom of this, when you take a screenshot, make sure I can see it. Because some people would be like, yeah, this is the piece. And I'm like, okay, well, where's the text? And then I can't tell. So then I just can't give you credit. So, when you take a screenshot, make sure I can see the text. Again, that makes my life easier. And then it reduces your chances of not getting points that you did. So, yeah. But yeah, that's basically all the assignments I'm doing in class today. You do have homework every week for this class. It does build off of what you learned in class that week. So in this case, we mainly learned sketching, extruding, and revolving. So your homework is to create your own chair, right? So this chair doesn't have to look exactly like the one here on the screen, as long as you follow some basic requirements that make something a chair. You can make it look as strange or as normal as you want. I've gotten chairs that look like super super wide and demented, and it's like funny. And I've gotten like really cool chairs that look like I would really want to sit on it. So you can make really weird stuff. You can make very normal stuff. That's totally fine. The point of these homeworks is just to allow you to exercise these skills independently. Because personally, the best way for I learned how to CAD was just starting my own project, right? I'm like, I want to make something really cool, and I'll kind of figure out the tools along the way. So in this case, I'm just giving you a requirement, like make a chair, and then you can do whatever you think is necessary from the stuff that you learned to create it, right? So again, it's very relaxed. I'm not going to be like, oh, this chair has to be this tall or whatever. You can make it however you like. It's just giving you an opportunity to show to me that you're learning what I teach in class. So yeah. Again, if you have any questions, feel free to ask. We're here for you. But yeah, that's pretty much it for week 1. I'm gonna, stick around for a little bit, help people out. But if you think you're chilling, good to go, I'll see you next week. Oh wait, yeah. In terms of assignment submissions, people have been asking how you submit your assignments. So if you go under course material, you can see here every week I'm going to post the slides that we use along with the rubric. So if you're curious on what I grade and what things are worth, there's a breakdown here. For assignment submissions, it's right here. So you just open it. It's a Google form. Please submit everything at the same time, because I will grade like every single submission. So if you just like submit assignment 1 and then you submit assignments 1 and 2 and then you submit like everything, then I'm gonna grade all 3 of the individual like submissions. So to reduce that, it's more helpful if you just do it once, unless like you submit and you're like, oh shoot, like I read the rubric and I added something. I mean, that's fine. But just keep in mind, I'm going to be grading all of the submissions. So it's ideal if you just submit them all at the same time. But yeah, basically, you just fill in your information here. Please write Purdue@edu here, because some people forget. And then in the grade book, it's like a super fat spreadsheet. If it doesn't have Purdue.edu, it'll think that you didn't submit the homework, and I'll have to fix that manually. So if you want to reduce the amount of work for me, that's preferred. If you put Purdue.edu, that would be nice. But yeah, when I grade these, it'll be sent to the email, like the Gmail associated with the Google submission. So you won't get an email to your Purdue email, but like you'll get it from this email. Like the scores will come out there. But yeah, that's where you submit. Again, just screenshots and upload them. For the attendance and absence forms, they're also posted here under the course material tab. So please fill that out if you haven't already. A little incentive for all of you: if we have over 90% attendance accounted for, so that includes being in class, but also absence forms. If we can maintain like 90% throughout the course, then I'll bring free food on the last day. So please just like fill them out and like bug your friends if they haven't. I'll try to remind you as well. But if that's a little incentive for you to come to class or at least fill out the forms, I'm going to give that to you. So yes, I really want to bring free food. I will be more poor, but I will be happy because all of you are committed to the class. So yeah. Other than that, that's basically all I have for you this week. I will see you all next week, hopefully, unless you have exams, which I do, but I'll be here. But yeah.
I was gonna say something. I forgot what I was gonna say.
Okay.
I wasn't going.
Oops.
If it wasn't anything like